Okay, good morning. Next we are going to see about hierarchical clustering. So in last class we discussed about k-means algorithm. So we know clustering. So clustering nothing but grouping of similar objects. In k-means clustering, it nothing but it is a partitioning algorithm. In partitioning algorithm, we use distance measure Manhattan or equidistance. We easily grouping cluster by means of data points and cluster center. We easily group the cluster. So here in hierarchical clustering, similarly it groups similar objects into groups. So here two types of hierarchical clustering available. One is agglomerative and another one is divisive. So in agglomerative, it is a bottom-up approach. Divisive, it is top-down approach. So here we concentrate only on agglomerative. So in agglomerative, since it is a bottom-up approach, so we start with many small clusters and merge them together to create bigger clusters. So a simple algorithm for agglomerative clustering is given. So first we have to compute the distance matrix between input data points given to us, and after that let us assume let each data point to be an individual cluster. We repeat, merge the two closest cluster, update the distance matrix until only a single cluster remains. So this is an algorithm steps for agglomerative hierarchical clustering. So here key operation used in agglomerative clustering is distance between two clusters. So in this example, for example, agglomerative clustering, individually we consider P, Q, R, S, T. These are all the data points given to us. So individually we first consider each data point to be an individual cluster. After that we have to merge the closest cluster. So first we merge P and Q and S and T, and after that we merge R, S, T, and after that we merge all P, Q, R, S. So until a single cluster we repeat this algorithm. So in what basis we merge this cluster means in basis of distance measures. Yes. So distance between two clusters. So there are three different distance measures available in hierarchical clustering: single link distance, complete link distance, and average link distance. So in single link distance, nothing but minimum distance between any two objects. That means minimum of d of x comma y. Whereas in complete link distance means maximum distance between any two objects. Nothing but maximum of distance of x comma y. In average link distance, nothing but average distance between any two objects. Nothing but average of d of x comma y. So in this any of one distance measures, we apply in hierarchical agglomerative clustering in order to find out distance between any two cluster, and after that we merge the two cluster until single cluster remains. So in hierarchical agglomerative clustering, first we have to make each data point as a cluster, and after that we have to take the two closest or two closest cluster and make them into one cluster. Repeat step 2 until there is only one cluster. Okay. In hierarchical clustering, a common term we here use this dendrogram. So dendrogram is nothing but it is a diagrammatic representing a tree. There is a tree-like structure. In hierarchical clustering, a dendrogram like tree structure illustrates the arrangement of clusters. So an example is given below. So here we consider data point A, B, C, D, E, F, G. First we merge B and C, since B and C are the closest cluster. So since we merge B and C, and after that we merge D and E, and after that we merge F and G, and after that we merge A, B, C together, and after that we merge D, E, F, G, S together, and finally we merge all data points together into a single cluster. This is the step involved in hierarchical agglomerative clustering. Now we are going to see a simple example to understand hierarchical agglomerative clustering. Since we all know hierarchical agglomerative clustering is a bottom-up approach, here we use the concept merging concept. If we first we consider individual data point as an individual cluster, and we are going to apply the any one of distance formula. We see three different distance formula: single link, complete link, and average link. So here in this example, we consider one dimensional data set, for example 7, 10, 20, 28, 35. So here input we have 5 data points. We have to perform hierarchical clustering and plot the dendrogram to visualize it. Dendrogram nothing but tree like structure to visualize cluster, arrangement of cluster. In this example we use single linkage. So single linkage nothing but distance matrix of minimum distance between any of two clusters. So here we going to write all data points 7, 10, 20, 28, 35. So in first iteration, so the distance between 7 and 10 is 3, and 10 and 20 is 10, 20 and 28 is 8, 28 and 35 is 7. So here we get distance value as 3, 10, 8, 7. So here 3 is the minimal distance point. So for 3, 7 and 10 is the data point. So we merge 7 and 10 cluster as a single cluster. So 7 comma in second iteration we merge 7 comma 10 and remaining 20, 28, 35. So next minimal distance is 7. So then here in second iteration we merge 28 and 35. In third iteration 8 is the minimum distance point. So we merge 20 with 28 and 35. So finally we got only one value 10. So we merge everything as one cluster. So here in dendrogram structure, initially in first iteration we merge 7 and 10. In second iteration we merge cluster 2, 28 and 35. In third iteration nothing but cluster 3 we merge 20, 28 and 35. And finally all individual clusters are grouped into single cluster. So this is the concept behind in hierarchical agglomerative clustering. Thank you.